Welcome to the GaN Talk podcast, brought to you by EPC and hosted by Maurizio Di Paolo Emilio, Marcom Director at EPC. This show brings to life the stories behind GaN technologies and products. In each episode, you'll hear engineers, executives, and academics share insights on the challenges and opportunities shaping the GaN market. Here is your host, Maurizio Di Paolo Emilio.
Hello everyone, and welcome to this new episode of GaN Talk podcast. So today we'll talk about the new release, EPC2378. So as you know, as AI data center, telecom infrastructure, and high-performance computing continue to request power demands higher, efficiency and power density are becoming critical differentiators. So today we explore EPC latest GaN innovation, as I mentioned, the EPC2378, and what it means for the next generation power conversion. We have published the new press releases, so this device supports up to 101 amps continuous drain current in a compact PQFN package. And our guest is Alex Liddell, EPC CEO. It's a great pleasure to welcome Alex to the GaN Talk podcast. Hi, Alex. How are you doing?
Hi, Maurizio. I'm doing great.
Good. Thank you. Thank you for being here. So let's talk about this new release. So what makes the EPC2378 technically different from previous generation of GaN eGaN devices and competing silicon MOSFET solutions in synchronous rectification?
So, the EPC2378 is a whole new generation of GaN technology, our seventh generation. In the past, we've not even attempted to make 25-volt devices because they really couldn't compete effectively against the best MOSFETs. But now this 2378 with 370 microohms of on resistance really makes a big step forward beyond not just GaN, but beyond any MOSFETs.
Good. So beyond low RDS-on, so EPC highlights the importance of the low RDS-on times QG figure of merit. So why is this parameter becoming increasingly critical in modern high-density DC-DC conversion?
So the on resistance of the part being extremely low, but you also need to have low input capacitance. And QG is a measure of how much charge it takes to turn the device on and off from the input side. As we go to higher frequencies, and that's important for higher power densities and faster transient response, you have to turn on and off the device more. And that means that you're exercising this QG on and off more. Now, GaN devices are much, much lower in QG for the same on resistance than MOSFETs. By the way, also important as you go to high frequencies is the R-on times the output capacitance, or QOSS. And again, these GaN devices are many times better than the incumbent MOSFETs at 25 volts.
Good, thank you. So tomorrow is PCIM. PCIM will start tomorrow, probably one of the most important power electronics conference, the biggest in Europe for sure. So tomorrow it will start the new edition, 2026. It is always a key moment for the power electronics industry to showcase what's next as we approach to this event. What technology trends are you expecting to dominate this the conversation this year, and what can visitors expect to see from EPC?
Well, first of all, PCIM is just a lot of fun. I get to see colleagues and friends that I've known for many, many years. It's a terrifically important conference for the world of power conversion and intelligent motion. That's exactly where our GaN devices are positioned. I think that there's a lot of talk today about two big things. One is AI. Everybody's talking about AI. And the second one is robots, humanoid robots.
Yep.
And those are both, very heavily in the middle of our GaN target. Our EPC GaN devices have been on AI servers for almost 8 years now. I think we're the only GaN on an AI server card today. And with these new parts like the 2378, we will have more sockets on the board than ever before.
So talking about EPC2378, so higher switching frequency often enables smaller and more compact power architectures, but it can also introduce new design complexities. So how does the 2378 product help engineers push frequency higher while on the same time maintaining efficiency?
Well, so, when you go to higher frequencies, you need to have lower capacitance, and that's where the 2378 distinguishes itself from any prior GaN generation and also from any MOSFET generation. So, in the past, if you go to higher frequencies, it just became too inefficient. Now with the 7th generation, we see people pushing, instead of 700 kilohertz, they're pushing 1 and 2 megahertz for their buck converters, and the LLC converters that we see out there are far more power dense because of these tiny little devices compared to their MOSFETs with their very high efficiency.
So this product is EPC2378, is optimized for secondary side synchronous rectification in 48 volt to 12 or lower LLC converters. So why are these architectures so important, particularly important nowadays?
So today, most of the NVIDIA servers have a 48 volt input to the server card and 12 volt distribution on the card. And so you need a 48 to 12 volt converter, actually several of them. And real estate on that server card is very expensive. So they want it to be as power dense as possible. So you're seeing power densities in the range of 6,000 plus watts per cubic inch as being the norm for a 48 to 12 volt converter. Now, there are also many board architectures that are 48 to 6 volts. Also LLC topologies, sometimes HSC or hybrid switch capacitor topologies. And those also require very, very high power densities. And again, these devices, these 2378s, are the best devices that you could use for either one of those outputs.
So as you said, AI is a hot topic. AI infrastructure is clearly a major growth driver feature. So obviously, power semiconductor requirements evolving over the next years, and where does EPC believe GaN has the biggest competitive advantage?
So we calculated it out for the new generation of Vera Rubins. And there is more than $100 worth of power semiconductors for every kilowatt of power consumed by a Vera Rubin class GPU. Now, Vera Rubin class uses anywhere from 2 to 4 kilowatts. So just think of that in terms of how much semiconductor content. How much of that is GaN the best in? About 85% of it. So GaN has a huge market, about $88 per kilowatt for AI servers going forward. And in every one of those $85, it is the best component in the world.
So let's talk about thermal. So as the power systems become denser, so thermal management becomes a limiting factor. So from a system level perspective, so what advantages this product, EPC2378, would offer engineers targeting maximum power density?
So as we roll into the Vera Rubin class of servers, we no longer have access to airflow. So it's basically fluid cooled through a cool plate. So what's important is to be able to connect to the device as efficiently as possible from a cool plate. The 2378 has dual-sided cooling. The back surface directly connects to the semiconductor surface, not to some heat sink that's soldered onto the semiconductor surface. So it's extremely efficient in getting the heat out. But of course, the best way to manage thermals is not to generate the heat. So if you have the lowest on resistance part with the least amount of switching losses, you will generate the least amount of heat that you then have to suck away.
Thank you, Alex. So, in conclusion, for designers, electronics designers, engineers moving from silicon MOSFET to GaN, reliability, as you know, and long-term robustness are key considerations. So, what are the most important factors engineers should keep in mind when making this transition? What consideration would you like to share regarding long-term performance and system reliability?
Gallium nitride is intrinsically more reliable than silicon because it has a stronger chemical bond between the gallium and the nitrogen. So thermal effects don't really impact the semiconductor reliability very much in GaN at all. But what is the central wear-out mechanism for GaN, as well as for MOSFETs, is thermal mechanical stress. So, we advise our customers, first look at the thermal mechanical design and make sure the thermal mechanical design meets your mission requirements. We can help with that. There are many options on how to design something for a specific thermal mechanical environment, certain amount of temperature cycling, certain amount of ramp rates, etc. We can help with all that, but that is your first point of design for long-term reliability and robustness.
Thank you. And for more information, you can download, the audience can download the latest our report, the phase 18 report you can download on epc-co.com. Thank you, Alex. Thanks a lot for this wonderful conversation, for joining us GaN Talk podcast. I wish you a great day and speak soon.
Thanks very much, Maurizio. Let's have fun at the show.
Thank you, everyone, for listening. See you soon.